Again, I'm going to have a root node to start with. I'm going to have my function that tells me what I'm looking for. I'm going to pass in one other function. I'm going to call it the less than function. And it has the property that it will say, it will tell me whether the thing I'm looking for is less than the current value or not. With that change, I make a very simple change to my code. And the change is highlighted right here. As before, I'm going to have a stack. It's going to keep track of the things I've got there. I'm going to first check to see, is the first thing in the stack what I'm looking for? If it is, I'm done. If it isn't, I'm going to apply my less than function to the stack. And if it returns true, it tells me the thing I'm looking for has to lie somewhere down the left branch. And so I'm only going to push that child onto my stack. If it's not true, then I know it has to lie, if it's anywhere, down the right side. And I'm only going to push that child, if there is one, onto the stack. That's the only change I'm going to make here. It's a simple, basically ordered search. And if I were to run it, and let's run it over here, I'm going to come over to my code and I'm going to find, I've got the code for that. So in fact, let me do the following. I'm going to say, let's call path26 be what I get by calling binary with path. I'm sorry, I've already done that one, haven't I? So I want to basically just use an ordered search here. Let me go back and do that one. I already did that case. So I'm going to just do an ordered search on this. And so let me do, in fact, that first search binary ordered. And I need to have N5, and I need to have find 6. I'm pretty sure over here I created another thing called less than 6. There it is. So I'm going to pass in less than 6, which is a piece of code that simply returns the right things. It says true. And so let's think about what happened if I actually ran through that code. And here it is.